Okay, good morning Year 10s. We've made this video for those of you that weren't able to make it into school to do the chemistry, physics and biology. So this should take about 20 to 25 minutes, which is what we had for those Year 10s coming in for each science course. Okay, so we thought we'd review chapter 5, energy changes, the first couple of lessons in that chapter. Some of you have already done it, some of you haven't. So it was a good review for those of you that have already done it, and it was a good introduction for those of you who haven't done it. Okay, so the learning outcomes are, you want to be able to describe what exothermic and endothermic reactions are in terms of energy transfer and temperature change. You also need to be able to draw something called reaction profiles for our exothermic and endothermic reactions. And number 3, you need to be able to define activation energy and overall energy change. Okay, so exothermic and endothermic reactions. Okay, so our definition of an exothermic reaction is one that transfers energy to the surroundings so that the temperature of the surroundings increases. So a reaction occurs, we've got our reactants coming together to make a product. During that interaction, energy is going out of the chemical reaction, okay? It is exiting the reaction. Now that energy could be in the form of heat, it could be in the form of light, it could be in the form of any type of energy, okay? Exo means that energy is exiting our chemical reaction. And if we had a thermometer, the temperature would increase, okay? So our exothermic reactions, energy is exiting, our thermometer increases, our temperature on our thermometer increases. Okay, endothermic reactions. So an endothermic reaction is one that takes in energy from the surroundings, so the temperature of the surroundings decreases. So endothermic, our energy is entering. That's one way you can think about it. Again, it can be heat, it can be light, it can be any form of energy, but it's usually heat or light. Endo means energy is entering our chemical reaction. And if we had a thermometer, the temperature would decrease. Okay, so endothermic reactions, energy is entering. If we had a thermometer, it would show that the temperature is decreasing. Okay, I'd like you to try this little task just to summarise what we've been through there. So you can pause the video, copy down this word fill. We've got a word bank at the bottom for you to fill in the missing words. So pause the video now and have a go at this task. Okay, so let's go through those words. So exothermic reactions transfer energy from the reacting chemicals into the surroundings. We can measure the energy transfer by measuring the temperature increase in the reaction. During endothermic reactions, there is a decrease in temperature. This is because energy is transferred from the surroundings into the reaction chemicals, and our thermometer is the surroundings. It's not the chemical reaction. Okay, so our thermometer counts as the surroundings. Okay, so energy is going out of the thermometer. That's why the temperature decreases. Okay, so correct any ones that you got wrong. If you got some wrong, go back over the last 2 slides and make sure that you are understanding the difference between our exothermic and endothermic reactions, what's going on in terms of energy transfer and temperature changes. Okay, on this next slide, I've got 5 different chemical reactions. Some of them are exothermic, some of them are endothermic. So pause the video, write down our 5 reactions, which are respiration, neutralization, photosynthesis, thermal decomposition and combustion, and we're burning fuel. So write those 5 reactions down. Think about what you know about them. Okay, what do you know about them? You've got clues in the pictures to tell you about if energy is going into the system, if energy is entering our chemical reaction, or energy is exiting our chemical reaction. 2 of these are really important biological reactions, so you need to know them for your biology course as well. So pause the video, have a go at labelling which one's exothermic, which one's endothermic. Okay, so here are the answers. So respiration. This is a chemical reaction that happens inside every single living cell. And it happens, it's so useful because it releases energy. We have glucose, we have oxygen, making carbon dioxide and water. And in that chemical reaction, energy exits, energy is released. So therefore, it is an exothermic reaction. Our neutralization reactions, where we've got acids and alkalis coming together to make salt and water, is also always an exothermic reaction. We will often see quite high temperature increases in these neutralization reactions. Okay, on to the next one, photosynthesis. So photosynthesis occurs in the chloroplasts, in green leaves. It needs sunlight. Photosynthesis cannot happen without sunlight. So energy is entering our chemical reaction. So therefore it has to be endothermic. Okay, if we took the sunshine away, photosynthesis would not happen. We'd still have carbon dioxide, we'd still have water around, but they would not react together to make our glucose and oxygen. Next one, we've got thermal decomposition. So we've got our test tube with something green in it with a little flame underneath it. That flame is supplying heat to that chemical, or those chemicals, to make it decompose. So there's actually one chemical in there that's breaking apart, decomposing because of the heat energy going into it. So we've got energy entering our chemical, so therefore it has to be an endothermic reaction. And then lastly, we've got combustion, which we've got energy coming out of that, and light, that's why we use it so much, and we know that's an exothermic reaction. So again, if you got some of those wrong, you should maybe go back and read up about those reactions. Those are the only 5 reactions that you will be asked about in terms of exothermic and endothermic reactions. Okay, so we have gone through what exothermic and endothermic reactions are in terms of energy transfer and temperature change, so we can tick that off. So now we're going to get on to drawing our reaction profiles for exothermic and endothermic reactions. And we need to be able to define activation energy and overall energy change. Okay, so we'll start off with our exothermic reaction profile. So a reaction profile is monitoring the energy of our reactants and our products through the course of our reaction. Okay, so if you draw up these axes into your book, along the bottom we've got reaction progress, so how far the reaction is going from the time we put the reactants together until the time we just get products left. And at the side on the y-axis we've got the energy of our chemicals. Okay. Now for our exothermic reactions, our reactants start off at a higher energy than our products. Because energy is exiting the reaction, the products are going to have less energy than our reactants. Okay. Now we can't simply draw a straight line between our reactant and our product energy, because every chemical reaction requires a little bit of an energy input to get it going. Okay, and the way we draw that is we draw this barrier. It goes up and over to the products. So that's showing that we need a little bit of energy to go in to get the reaction to start. So for example, if we have methane, which is our gas that comes out of our gas into our Bunsen burners, for that methane to react with oxygen, we need to give it a lit match to start that reaction. We can take the match away afterwards and it continues to burn and combust, but it needs that little bit of energy to start it off. So that's that barrier there. We call it an energy barrier. This is actually our activation energy. It's the minimum energy that the reactant particles need in order to react. If our reactants don't have enough energy, if they're not above that, they're not going to react and make our products. Okay. Now the second key phrase we needed to know the overall energy change. That is the difference between the reactant's energy and the product's energy. And I've drawn it on in the purple arrow here. For an exothermic reaction, it is always negative, okay, because the reactants have more energy than the products, and it shows that that amount of energy has left the system. So you need to sketch that into your book. It's a really common exam question for you to draw out a reaction profile and to label the activation energy, to label the overall energy change. Or they might give you one and ask you, is it an exothermic reaction or an endothermic reaction? So you really need to know these, and you need to know the difference between the exothermic reaction profile and the endothermic reaction profile, which we will draw now. So we're going to have the same axes, the reaction progress along the bottom, energy of chemicals up along the side. Now we've got one line for our reactants there. In an endothermic reaction, energy is entering our chemical reaction, so our products are going to finish at a higher energy than our reactants. Again, we need a little bit of an energy boost for our reaction to happen. So there's our barrier there. The activation energy is that minimum energy that the particles need in order to react. So we take the arrow from where the reactants are up to the top of that barrier. Okay, and then we can draw in our overall energy change is the difference between the reactant's energy and the product's energy. It is a positive value for an endothermic reaction. Okay, so you need to make sure that you know how to recognise an exothermic reaction profile and an endothermic reaction profile, or you might be given them and asked which one's which. Okay, fabulous. Now the last thing we did in the lesson, but we didn't have very long, was to do some exam questions, and the mark scheme was also given out in some sessions when we had enough time for people to mark their exam questions. I will put those marks, those exam questions and mark scheme on Show My Homework for you to have a go at. Okay, so let's just go through what we have learnt today. We've described what exothermic and endothermic reactions are in terms of energy transfer and temperature change. You've been able to draw reaction profiles for both our exothermic and endothermic reactions, and you need to be able to define our activation energy and our overall energy change for those profiles. Okay, thank you very much for your attendance and see you soon. Bye.